Hello, everyone. So, another thing that I will cover in this topic is violating the correlation assumptions. Of the 7 assumptions over here, I'll just focus on the 3 which you can see on the scatter plot. So, the task at hand is given a question, can you actually go from the question towards making the scatter plot of a problem where the correlation assumptions are violated? So the question is, make a scatter plot between 2 variables which break linearity, homoskedasticity, and no outlier assumption at the same time. So let's start with the easiest assumption to break, which is the linearity assumption. If it's not a straight line which connects y and x, then it's not linear. So for example, let's assume that we have a function such as y is equal to ln x. Now this, as you can see from the shape of the curve, is definitely not linear. Now, if any points were assembled such that they were around an ln curve like this, then these points would break the linearity assumption. So if I have points like this on a scatter plot, then they are violating the linearity assumption because they're not lying on the same lines. Now, at the same time, we also want to break the homoscedasticity assumption. Homoscedasticity means that the variance for any given x is constant throughout the scatter plot. For all values of x, the variance is constant. Now, so let's assume for lower values of x, the variance we have is small, like this, but as the value of x increases, the variance increases. And then we have, as the value of x goes really large, the variance increases definitely more. So let's say something like this. So now if you look at the scatter plot, what you see is at the start, when x is small, the variance is also small. Then when x has very high values, the variance of x is also very large. This means that the homoscedasticity assumption has been broken. The third assumption that we are trying to break is the no outlier assumption. So what correlation and regression both are dependent on outliers. If they're outliers, then the value of correlation would be really, really incorrect. So any value which dissociates from the general trend will be considered an outlier. So for example, if I put 1 point over here, that's an outlier. Or if I put 1 point over here, which is far from the basic trend, that's an outlier. So now we have all 3 assumptions being violated. The non-linearity assumption, the linearity assumption, because this graph indicates that the function between y and x is nonlinear. The homoscedasticity assumption, because as x increases, the variance of the y values also increases. and the outlier assumptions. There are points which will distort the correlation value. And for this graph, if we calculate the correlation value, it will be misleading and will not give actual relation between X and Y. Thank you for watching. Please like and subscribe.